All right, good morning, everyone. This is day 4 AM. We're going to be getting into LangGraph and Agents Foundation, building onto the current week of LangChain. You guys have been implementing sequential chains and memory RAG into your applications. Today, we're actually going to make it a little bit more complex, where before we had a you had chains just running more simply, just passing an output into an input into another method or function. But today we'll actually implement something where your application can decide which route it wants to take depending on the output that you get. We're also going to be getting into agents. You guys did get into that a little bit through one of the challenges, and the agent using tools to help you get your outputs and results. So, are there any questions before we continue? Okay, so today we have one lesson on LangGraph and agents. We have a lab and a challenge. We have our TLOs and ELOs. So today you'll learn to build intelligent stateful workflows that go beyond linear chains. LangGraph enables applications that branch, loop, and make decisions based on intermediate results, while LangChain agents let the AI choose its own tools autonomously. What are we trying to accomplish? We aim to give your AI applications the ability to think and adapt. By the end of this session, you will understand how to define type state structures that flow through workflows and create node functions that process and update state. You'll connect nodes with edges to build linear workflows, then add conditional edges for dynamic branching based on content. You'll implement iterative loops with quality gates, build flexible agents that choose their own tools, and understand when to use structured graphs versus autonomous agents. So before we actually, let's just go ahead and get into the lesson. I was going to make some references, but I'll speak through it as we go through. So, an overview of LangGraph and agents. LangGraph enables intelligent, stateful workflows that go beyond linear chains. Instead of rigid step-by-step pipelines, LangGraph lets you build applications that branch, loop, and make decisions based on intermediate results. Today, you'll learn how to create graph-based workflows with nodes, edges, and conditional logic, understand when to use structured graphs versus flexible agents, and combine both approaches for maximum power. Why does LangGraph matter? Sequential chains force rigid linear workflows that can't adapt to intermediate results or handle complex decision making. Example, imagine building research assistant that needs to handle researching renewable energy, but if you find cost concerns, also research government incentives, and if those are substantial, compare both aspects. Sequential chains can't branch based on what they discover, but LangGraph can. So with the three different approaches, which are sequential chains, LangGraph, and agents, uh, a description of, again, of a sequential chain is a fixed step-by-step execution. And then for LangGraph, a graph-based with conditional edges, so it can branch out depending on uh, the output that it gets. So if it determines that if you think there needs to be more research done, it will branch out and conduct that research, then send it to that next step. And that next step could mean the analysis. For agents, AI chooses tools dynamically depending on what can help determine the output. But there are limitations. So for sequential chains, it can't branch or loop. For LangGraph, it's more complex to design, and agents are less predictable. So core LangGraph concepts, applications are built from nodes, edges, and state that work together to build dynamic workflows. But how does LangGraph work? So we have nodes, edges, state, conditional edges, and cycles. So nodes just represent individual steps or functions. Uh, Edges connect nodes and define possible paths. State carries information between nodes. Conditional edges enable decision making and branching. Cycles allow workflows to loop and iterate. There's an example down here below, but I'll tell you guys what uh, I'm thinking just going through this part right here beforehand, so that maybe you guys can understand it better and connect the two different examples. I kind of think about like say there's two buildings and they're 5 feet apart from one another. So those two buildings would represent the nodes. And then if you add a tightrope between them, those would be the edges. And then uh, the state is what carries the information between nodes. So say you have a robot or something that brings an object from one building to the other. Uh, the robot and that object will count as the data flow that's traveling between the two. Now, if you add a conditional edge, say there's a third building that's probably a little bit further away, maybe 50 feet away, and that one is not a tightrope. It's a wider path that you can take, maybe like a bridge. Uh, if you add a human to that, that'll be a conditional edge because then they'll be able to think about which path to take. So if they see that the better path to take is going to that through that bridge, then it'll take that path, depending on what it needs. And then cycle just allows workflows to loop and iterate. Now, the example that the lesson gives you, think of LangGraph like a flow chart. Each box is a node, each arrow is an edge, and the data flowing through is the state. Unlike a chain, the flowchart can branch into different paths based on conditions. Are there any questions so far based off of that? Okay. And this will make more sense while we're going through the lab too. I'll explain things a little bit better, but we're just gonna go through this lesson real quick so that you guys have the familiarity. So nodes are the building blocks. Nodes are Python functions that take state, perform work, and return updated state. So in this code block example below, we have the imports, and then we define the state structure with a type dictionary. So a type dictionary is not a regular Python class. It's a type hint that defines the shape of a dictionary. So think of it kind of like the blueprint. It doesn't support methods or anything. And if you try to put a function inside it, you'll get an error. It just tells Python what type of data a variable or return value should be. It's like a label that says this should be a string or this should be an integer. So in this case, within our type dictionary class, we specify there's a query, a research results, analysis, and step count. And this just flows through all your different nodes and can be updated within those nodes. So after that class, we have our first node function. Notice how it's not within the class, it's actually outside of it. So this node is our research node. So this is what takes in the query. This is going to be the initial step of the of the LangGraph application. So we define the research node, and then within the parameters, we specify what state we're using. So in this case, the workflow state. And then we have our type dictionary. we specify our prompt. So we want to research, and then we just pull in our query from that state. So whenever we put in a query, it will get thrown into uh, this key right here. So after our prompt, we specify our response. We just invoke the LLM with our prompt. And then we return a a star star state. So this pretty much means open up that dictionary and copy it to a new dictionary, and everything below it, just overwrite those specific keys. So for research results, it will take the content from our response within this node and overwrite whatever was in this research results key. For our step count, it will update the count. So this is saying get from the state, get that step count. And if it doesn't exist, so if this was not here yet, set the default to 0 and then just add 1. But if it's already there, say if step count was already at 1, it'll just add that 1. So this 0 is kind of just a default placeholder. So edges are what connects the nodes. Again, think of it like the tightrope or the bridge. So over here in this example, we create the graph, and the graph in LangGraph terms is another word, or yeah, it's another word for application. So whenever you hear graph in LangGraph, think of application. So we specify our workflow, and then we have a state graph. State graph is LangGraph's core class for building workflow application. It defines how your state flows through a sequence of nodes. And we're just specifying, again, the state that we defined up here. So it's going to be following that blueprint. And then we're going to add our nodes. So notice how we have 3 different ones: research, analysis, and summary. When we're adding the nodes, notice there's 2 parameters. We have a string, and then these are going to be actually our node functions. So this is just labeling those node functions with those strings. So for research node, it's going to be known as research, analysis node, analysis, summary node, summary. After you add those nodes, you're going to add your connections. So instead of workflow.add node, it's going to be workflow.add edge. So after you label everything, you're kind of just you're connecting everything. So think of this comma as that bridge or tightrope. So research will connect to analysis, and then analysis will connect to summary. And then if summary is your last step, you'll want to connect it to end, saying that that's the last step. So we're going to set our entry point, and that's going to be our research node. So the research node is what takes in that query and executes it. So after you throw in that query, it'll go to research. Then based on this workflow or graph, it will take the research and connect it to the analysis, analysis to summary, and then summary to end. After all that, all those connections have been made, you're actually going to compile it. So you're going to compile that blueprint and think of it as the build function. So it'll build everything together so that you can actually invoke and run it. So we took our workflow and we compile it. Think of it like construction. Someone's building a house. You have the blueprint, and then once you have that blueprint made from all these different setups, then the workers can actually start building everything. So after we compile it, like I said, now we can finally invoke it and get it up and running. So next up, we have our state. So it's carrying information. State is a type dictionary that flows through all nodes. Again, we have our class workflow state and then type dictionary. So we're just specifying that this class is not a normal class and it's not going to take any methods. It's just the blueprint. We have our users question. So the query, the research output is what gets stored in the research results. Analysis output gets stored in analysis. Final response, final answer. And then step count just tracks the progress. And then confidence is a quality metric. So step count kind of just is uh so it'll increase the count depending on how many nodes it ran through. So that's what step count is. So we go over our state fields again down here. Conditional edges. Conditional edges enable workflows that branch based on intermediate results. So decision functions, this decision function examines state and returns the next node name. For this example, we build a function named decide next step. We throw in uh, our state, so workflow state, docstring decides next step based on research results. So we'll set up a variable called research and we'll equal it to get the whatever was inside that research results in our blueprint and set everything to lowercase. So the next step would be saying, hey, if you find the word expensive in that output or high cost in that output, then return research solutions. And then if after that, it'll check if the research is less than 100 characters. It'll say research more. And we'll get into these a little bit more later on too in the lab. But if it doesn't find expensive or high cost in that output, it'll just send it straight to the analysis part. So adding conditional edges connect the decision function to route between nodes. So we'll take our workflow and then use add conditional edges. We'll specify our source node. So our again, research stands for our research node. It's what takes in that query. And then we have next up the function that actually decides which path to take. So we'll take the output from research, send it to this function right here, decide next step. And then within this function, decide next step, we give it a list or a dictionary of different paths it can take. So it'll either be research solutions, research more, or analysis, depending on what this step finds. So continue from branch nodes. So we'll add the connections again. So research solutions, if it finds out that it needs to go through this path, it will then take the output from research solutions and send it again straight to analysis. So notice how it took that extra step to do more research right here. If it goes to research more, it'll send it to analysis. An example, the workflow researches a topic, then decides if costs are mentioned, research solutions first. If research is too short, gather more, otherwise proceed to analysis. Does that make sense? Any questions? Again, we'll go through this again in the lab, and you guys will be able to visualize it better.
Yeah, I've got a question on the qualifiers.
Mhm.
So in our decide next step, the qualifiers are like just two words that are picked out. How how does that scale and how do you define those from a quality perspective?
Uh, can you ask that question again? Are you talking about these two right here?
Yeah, the so up above in so we're evoking decide next step. So right up
Mhm.
above in that function, it looks like we've got hard coded two words, expensive and high cost. If you scroll up to the, yeah, yeah.
Mhm. Yeah, so again, this part right here is just taking that whatever was stored in that blueprint or our state uh, within the research results key. So the research results is what gets outputted from that research node after the user puts in the query. That query will get sent to that research node. It'll take an output and store that output in our research results. Where is it at? It'll store it over here. So this state uh, flows through all these different nodes so that it it is constantly updated and uh, each node knows what is happening.
So
But
where does expensive and high cost come from? Are those like keywords within Lang chain, or is this tailored to a very specific query?
so these are pretty much up to the user. So if you're pretty much saying you in this step you're deciding when to conduct more research. So if you get a let me try to think of an example. If if you're giving a query that says, "Hey, can you tell me something about solar power?" and uh you get an output that doesn't have expensive or high cost, it's just gonna go straight to analysis. But if say the point of this of you sending this query is you want to build a solar power business. So you know you're concerned about costs and money and budgeting. So you want you decide, hey, if you see any words like expensive, high cost, uh percent, money, then do more research on uh on that on that topic. Does that make sense? I hope I clarified it a, a little bit. So
Yeah,
you're deciding what the conditionals are in order to conduct more research.
yeah, yeah. Okay, so it makes sense how it's functionally working now. I guess we just have to see it in action. It seems a little bit arbitrary that two words might be all you need to do to qualify a good
Mhm.
answer. That
Yeah.
seems,
Well, it's just an example, right? Of how you do it. Maybe here you would actually pass it to another LLM to make a semantic decision based on
Mhm.
expensive or high cost. Instead of just the strict hard-coded words, you would try to, read between the lines and see look into expense.
Yeah,
yeah,
you
that
can
helps.
yeah, you
Yeah.
can pretty much make it more complicated as you want. You don't have to stick to just, a keyword search, but you can make a more complicated conditional or even a function that analyzes that output of research results, and depending on it'll decide which path to take. But yeah, this is just an example. That's why it's just using the keywords search.
Yeah, no, thanks.
Mhm.
Uh, awesome. I got it now. Appreciate you.
Any more questions? Okay, let's go into conditional edge patterns. So we have a pattern of quality gate, content routing, error handling, and iteration control. For use case of quality gate, check if output meets standard implementation, route to retry or proceed. So again, taking those different paths. Content routing, different paths for different topics, route based on keywords, error handling, recover from failures. It'll route back to the fallback node, iteration control, limit retries, and check counter and state. Iterative workflows. LangGraph supports loops for workflows that improve results through iteration. So this is a quality-based iteration. It's evaluating that research quality out, that research, where is it at? Research results output. So it's saying set this variable research up, and for that variable, we're again getting the output from research results from our state. Again, notice how that state is being passed through each individual function and node. We're going to set up a word count, so length of that output, and then if it has data, so again, this is just an example, is checking to see if it has the words data, study, or research in it. And then this is pretty much, this function is setting a quality score. So we're initializing that quality score to 0. If the word count is greater than 100, the quality score will either will increase it by 1. If it has that any of these words right here, it'll increase it by 1. And if the word count is over 200, increase it by 1 again. And we see the same thing we saw earlier over here with this star star state. It's just saying create a new dictionary and overwrite the following keys into that state. So if there's no quality score, it'll add that quality score and uh, put the value as what it determined. We
The
have,
star star state, that's just like a spread operator, right?
uh, can you elaborate more on that?
It's going to take the state
Mm,
and then it's going to break it into its individual pieces, stick them inside of a new object because of the outer brackets, and then like just like you said, overwrite that one value, quality score with the new quality score, but leave everything else the same. Is that
yep,
right?
yep,
Okay.
exactly, exactly.
Okay.
Yeah, so pretty much just take that state and overwrite this, whatever keys come after it, and but keep everything else the same. All right. Next function we have should it continue? It decides whether to iterate over that function again or proceed. So or, instead of function, I'll be using node. So it'll reiterate over that node. So quality equals state, and then it'll get the quality score. Iterations, it'll get the iteration count. So earlier you saw step count. Now we have iteration count. Step count is actually the step count that increases every time you go through a node. Iteration count is for the whole cycle. So in this function, in this node, if quality is less than 2 and iterations less than 3, it'll continue with the research. Otherwise, it'll go to analysis. Any questions so far? All right. Now the loop structure. So Here we have workflow.add edge, so add that connection from continue research to quality check, and then a conditional exit from loop. This is that conditional edge. So this is just a regular one. Think of this as like that robot who doesn't have thinking, and then conditional edge as a human between the two buildings. So we specify our source node, so the quality check, where we will get our quality score. We take that output and we pass it to the should continue node. And then this right after it is the different paths it can take depending. So if it returns continue research, it'll go to this node. If it returns proceed to analysis from this node, it'll go to the analysis node. So the example says the workflow researcher researches, checks quality, and if the score is below 2 or 3, loops back to gather more information, and it's only allowed up to 3 iterations maximum, which is seen right here. So agents versus graphs, what's the difference? Understanding when to use structured graphs versus flexible agents is crucial for building effective AI applications. So let's look at the comparison in this table. So we're looking at 5 different aspects: control, predictability, debugging, flexibility, and best use case. So for control, LangGraph, the developer defines the flow. Agents, AI decides the flow depending on what tool it thinks is the best to use. For predictability, LangGraph is high, same path each time. Agents low, it varies by the task, so it'll use different tools. For debugging, LangGraph has clear step visibility. Agents is harder to trace since it's doing the thinking. Flexibility for LangGraph, it's limited to defined paths. Agents adapts dynamically. LangGraph is best for structured processes and agents open-ended tasks. But for agents, you'd probably, to get a really good agent, you'd need a lot of tools. When to when to use LangGraph, use graphs for a structured, repeatable process. So what's good for LangGraph is document processing, compliance checks, and data pipelines. So for document processing, loading, parsing, validating, and then storing. Compliance checks, reviewing, verifying, reporting, and approving. Data pipelines, extracting, transforming, analyzing, and visualizing. What are the indicators? Clear steps, compliance needs, error handling, and quality gates. So an example for clear steps: first research, then analyze, then summarize. Compliance needs, audit trails, consistent outputs, error handling, retry specific steps on failure, and quality gates must pass validation before proceeding. When to use agents for flexible exploratory tasks. So research assistants find what's relevant to this question. Code helpers figure out how to solve this problem. Customer support address whatever the user needs. Some indicators: open-ended, tool selection, variable steps, creative. Open-ended example: research this topic thoroughly. Tool selection: use whatever tool helps. Variable steps: different questions need different approaches. And creative: finding novel solutions. Any questions so far? So creating an agent. This is the more old way. This is the older way to create the agent. Now you have the tool. What's it called? The pretty much the new way to do it is to create functions, and then right above it you would use @tool. to specify those functions as the tools that the agents can use. You'll see that later on too in the lab. Hybrid approaches, you can combine graphs and agents for maximum flexibility with appropriate control. So routing to approaches. Here we route to structured or flexible approach. We get the user request, so the query, and if any word in the request is analyze, process, or validate, then we'll go with LangGraph. And if there's any words like explore, research, investigate, then we'll go use the agent. Otherwise, by default, we'll just use LangGraph. And below, we again show the conditional edge. We start with our source node. Then we pass that output to a specific node, and then we have the mapping. So an example, analyze quarterly sales data. It routes to a structured graph. Explore new marketing opportunities, routes to a flexible agent. The hybrid system picks the right tool for each task. And this kind of just goes over what we just went through with the different wordings. Analyze, explore, validate, investigate. So for best practices, state design, use type dictionary, so clear field names and types, track progress, include step count and iteration count, capture errors, add error fields for debugging, and be specific, avoid vague fields like data. For node design, we have single responsibility. Each node does one thing. Don't have it doing multiple things. That way it's easier to track and debug. We also should handle errors, wrap in, try, accept, return error state so that you can see it in the outputs. Clear naming, research node, not step one, and return full state, spread existing state with updates with that star state or whatever your state is named. So right here, workflow design, best practice, limit iterations. So set max iterations to prevent infinite loops. Think about that 3 max iteration. Add quality gates, check outputs before proceeding. Design for debugging, use verbose mode during development. And plan state flow, map out what each node reads and writes. So in summary, the components of the components that we went over for LangGraph and agents. So for LangGraph, we have nodes, edges, conditional edges, state, and loops. And then we also went over agents and then a hybrid of the two. Any questions? So my suggestion is just get comfortable with all these different components because then once you know what their specific jobs and roles are, then everything will click better. And we'll see that in the lab. So if there's no questions, I'll go ahead and proceed. All right, let me set this up on my other screen real quick. All right. So we're going to get into the lab. So we're building intelligent workflows with LangGraph and agents. This lab teaches you to build intelligent stateful workflows using LangGraph and LangChain agents. You'll learn how to create graph-based applications with nodes, edges, and conditional logic, implement iterative workflows that improve through loops, and build flexible agents that choose their own tools. We have our objectives, set up a LangGraph project with required dependencies, define state, create nodes, connect nodes, add conditional edges, and implement iterative loops. After that, we'll build a LangChain agent with custom tools. Yep, go ahead, Nick.
Do you know if LangChain has any visualization tools to help us visualize these complex workflows and loops and conditionals and stuff like that?
I believe it does. I have not looked into that too much yet, but I think it does. I think I
Okay.
saw it somewhere.
Because I was playing with it with Mermaid. I took the code from the lesson and stuck it in ChatGPT, and it made me a cool little visualization. I put it in the classroom channel,
Mhm.
and it helped me visualize it a little better, exactly what's happening and where it's going and all that.
All right.
But I figured they would have something built in. But
Mhm.
anyway, I'll look and see if I can find anything cool.
All right, sweet. Thank you for that. All right. So, getting into the lab, we're going to create our directory. I'm just going to name it lab. I'm going to cd into that directory. And then we're going to install our required dependencies. I have most of everything installed already. Now we're going to create a .env file just to store our AWS credentials in. And by AWS credentials, I mean just the CLI profile you will be using to connect to your AWS account. So, okay, yeah. So ls didn't work because it's .env. So look at all, it's there. Let's go ahead and open up that directory in our VS Code. And then store our AWS profile inside. So after you create your and set up your .env, let's go ahead and create a file called LangGraph lab.py. All right. And then now we can add the imports and uh, set up the beginning steps where we load our environment variables, create the Bedrock client, and initialize the large language model using Bedrock. And notice this is not highlighted, so let's change this to chat prompt template, change this to LangChain core, and then I will comment this out real quick because we're going to be using the newer version of the LangChain agents. This one, we can just change it to a lowercase t, and I'll get more into that later on as well. But this is how it should look. All right. So after we load our environment variables, create our Bedrock client, and initialize the LLM, we'll go ahead and define our state structure. So we have a class called research state that is a type dictionary. It is a state that flows through the research workflow that we are building. We have different uh, keys inside of it. We have query, research results, analysis, summary, quality score, iteration count, step count, and error. And we just have comments on what each of these steps do or what each of these are for. And if you guys have any questions too, just feel free to stop me. So again, type dictionary provides type hints for our state fields. It's the blueprint. It makes it easier to understand the code and helps catch bugs early. So query should be a string. Most of these four should be a string, quality score integer, iteration count integer, and step count integer. So we're going to create our initial state next. Again, this is not going to go inside that class because a type dictionary is not going to have any methods. So we create our initial state. We're pretty much setting values. So for query, we're going to set whatever query the user gives, and everything else is set to 0 or empty. We're going to add a test function. So it'll test the state creation. These three lines right here just creates the title. And then we're setting the state variable from that create initial state node. And then we're throwing in the query that we want over here. So that's the only thing that's going to be within our query from that test. We're then going to print out everything else and return the state. Let's go ahead and run that test real quick, see what we get outputted. So it did save our query over here, and everything else is still 0 that we printed out. Let's just uncomment this real quick. Now we're going to create our node functions. Clean this up a little bit. So what I'm doing here is just highlighting it and pressing tab to shift it over. All right, so for our nodes, we have our research node, analysis node, and summary node. So for our research node, we're passing in our state. So this will gather information on the topic. We're printing out a statement that says investigating this query. And then we have our prompt, research the following topic and provide comprehensive information, including key facts, recent developments, and important considerations. We throw in our query as the topic and then saying provide detailed factual information. So first we're going to try invoking the LLM and storing it as the response. Then we're going to take that content from that response and save it to our research results variable and setting error to equal none. If it gets any errors, then it's going to uh, run through here. So research results will be empty and it'll give us our error. After that, all that process has been completed, after it queries the LLM, we're going to return our new dictionary with updated keys and out and values for research results, step count, and error. So this is the output for research results, which again is the content from the response of the LLM invocation. And then we're just increasing the step count. And the error just gets stored in the error. For analysis node, it's the same thing. We're passing in our state. It'll analyze research results. It'll print out that it's analyzing it. And then we have our prompt analyze the following research and provide insights. Research results, we're passing in uh, that key from the state research results. So it's going to be the value. So the output of what was from this node. And it's saying provide key insights and patterns, important implications, and areas that need more investigations. So from that prompt, it'll invoke the LLM, save it to a response. It'll take the content and set it as analysis, set the error back to none. And again, if there's an error, it'll throw it our way. And after that, we return everything back. So we have the new dictionary with the updated keys of analysis, step count, and error. Summary node does the exact same. So it creates the final summary. We have our prompt. So create a comprehensive summary based on this research and analysis. We throw in our original query, our research results, and our analysis. And says provide a clear, well-structured final summary with key takeaways. So it'll invoke the LLM again, and if there's an error, it'll throw it our way, and it'll update the dictionary. So the summary will change, the summary key, step count, and error keys will change. Any questions? Hey, let's go ahead and add a test function to test it out. So we have some print statements, and then we're creating the initial state with that query. We're testing the research node. So we're passing in that query from the state into that research node. And then we have some print statements, and it's testing out all of our other nodes, passing in that state as it gets updated. So let's go ahead and run that. So notice the step count is increasing as it passes through each node, and it's giving us the length of the outputs for each one. So it is working. Any questions so far? Go ahead and comment this out. Now let's create a linear workflow. So we're saying we're creating the graph, again, in this case, the application. So for our workflow variable, we're passing in state graph and then our state. So we add our nodes. So adding the nodes is pretty much just labeling those different nodes we just created. So research node will be research, analysis node will be labeled as analysis, summary node as summary. Then we add our connections, which are edges. So this is a linear flow. Research will connect to analysis, then analysis will connect to summary, and summary is the last step, so it'll connect to end. We set our entry point where the query should be set to, or the first step in the process, and that will be set to research. So if you go up here, research is the research node, so this will get run first. We build it, so we compile it. Now, now we're able to invoke the application and actually utilize it, and we return the app. Let's add a test function. So we have some print statements. We create our workflow, which is the function we just added. And then we create the initial state. So we're passing in the query, electric vehicle adoption trends. We run the workflow. So we're setting final state to the invocation of the app using the initial state. And we print out our results and return the final state. Let's go ahead and test it out. So the research node is working. It's investigating and doing research on electric vehicle adoption trends. Then passes on to analysis node. And then passes it from analysis node to summary node, creating the final summary. So the workflow results, we had 3 steps executed. We list out the length of the characters in research output and analysis output. And then we have our summary, sum of our summary. And the reason why we're only getting some of it is because we set the max characters to 200. Any questions on that part? All right. So for part 4, we're now going to do a conditional workflow instead of a linear workflow. So our first node is our cost research node. So this ties back into what we were going over the lesson, Troy, with if it finds anything with cost or expensive, then it'll be sent to this specific node and then sent to the analysis node. So it'll add that extra step. So
That's
we
cool.
so we create our prompt. So the research is about our query. Uh, so it says the research about the specific query mentioned cost concerns. Now I want you to research the output from research results, limit it to a maximum character of 500. And then it says research solutions, alternatives, or ways to address cost concerns. So with that prompt, we'll try invoking our LLM, and then we'll set a variable called enhanced to include our output from the research node and include the content from this specific node that we get. So it'll have the original output and then the new research output. So if there's an error, it'll throw an error, and then we update the dictionary. So it'll save the new dictionary, changing the keys and values of research results and step count. Next, we have expand research node. So if there's more research that needs to be done. So our prompt says the initial research seems brief. Expand on this topic. We give it our query. Then we give the current research that we found from the research node and says provide more comprehensive information with specific examples and data. We invoke our LLM. Then we set the enhanced variable this time to the original research node output, and then our expanded research instead of the cost solutions output. So as you can see, there's two different paths depending on what it found from that research node. And then we return the state with the updated research results key and step count. And then this is actually what decides which path to take, whether to go to the expand research node or the cost research node. So for our research, we're just getting the output from our research results. So it checks for cost concerns. So again, if there's any words that say expensive, costly, high cost, price in the uh, research node output, then it will uh, return cost research. And then if the research is too short, it's less than 300 characters, it'll say research too brief, and it'll give us expand research. And remember, there was that mapping in that conditional edge. So it'll have like cost research, colon cost research. So this is just returning that string cost research. So it knows which key to go to in that mapping within the conditional edge. And then the value is actually going to stand for the node. So that's the label for the specific node that it'll go to. So cost research will be sent to the cost research node later on once you do workflow.add node and then create those labels in a different function. It'll know which node to head towards. So it checks for cost concerns, and if the research is too short, if it doesn't find anything uh, that matches those criteria, it'll proceed normally and return the analysis portion. It'll make more sense as we go through, but are there any questions? Is it kind of making a little bit more sense, Troy?
Yeah, I'm seeing some, I'm imagining some pretty cool use cases.
Good, good. Okay, now we're going to build the conditional workflow. So we just created the nodes and the functions. Now we're actually going to build it and compile it. So I guess the workflow would be create your functions and nodes, and then after you do those, that's when you do the add edge, add nodes, add conditional edge, and then compile to actually put everything together. So this is what we just added, the create conditional workflow function. It creates a workflow with conditional branching. So we're creating the graph or application with research state. And then we add in all our nodes. So we have our research node, cost research node. This is what I was talking about. So uh, notice how over here we have cost research and then cost research. This first cost research comes from uh, the decision function. So if it finds any of these words, it'll just return this string, which will point it in the correct path within this dictionary. And then so it sees the cost research over here. Now for the value, we have cost research as well. This cost research comes from the labeling up here in the nodes. So we find cost research and it will execute this specific node. So my point in showing you guys that is Uh, this can be two different strings. So cost research is just the output from the decision function, and then this value is just whatever you label uh, the next node to be ran. So if it sends back cost research, it'll go to cost research, expand research. So our expand research node, and then analysis goes to analysis node. So that's our conditional edges. After we create our nodes, then we actually create the connections between them. So from our cost research, after we get that output, we want that output to get mapped to the analysis. The expand research will go to analysis, and then from analysis, it'll always go to summary, and summary is the last step, so it'll be connected to end. We set our entry point, which is always our research node, so where we're passing in our query, we compile it, and then we return the app. Let's go ahead and add a test function and run it. So let's actually go through what it's doing. So we have some print statements. We initialize our app, and then we have some test queries. So we have uh, our query in the beginning. So we have solar panel installation costs, AI, and then benefits of meditation for mental health. The second part is just the expectation of what it should be doing. So this query should trigger cost research. This query should trigger expand research. This query should go straight to analysis. So for each query and the expected and that test queries printed out, and then we create our initial state. We invoke that initial state, and then we have some print statements. Let's go ahead and test it out. So for the first query, solar panel installation costs, what's expected, which got printed out, and we had up here. Where is it? It got printed out over here of what's expected. So it should trigger cost research. So the research node is investigating the solar panel installation costs. So our query, and then it's giving us the decision it made. So it found cost concerns. So within the output of the research node, it found one of those key terms like cost, expense, budget, and now it is sending it to the 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 add-on node. So the cost research node. So the cost research node is finding cost solutions, and then after it gets sent to the cost research, it gets sent to analysis. This one says it's sufficient, so it didn't match any of the criteria, so it gets sent straight to analysis, and then same thing for our third query. It's proceeding straight to analysis. One thing too is to make to think of better ways to implement these extra nodes, these different paths, because the first time I ran it when going through this lab, it all three queries went straight to analysis, but then when I ran it the second time, the uh the first one then got sent to the cost research node, and that's because remember every time you invoke an LLM, it'll have different outputs. So one output may not have those key terms, so that's where your point comes in, Troy and Nick, with creating really complex checks checks for your use case. Any questions? All right, let's comment this out. Move on to part 5, implementing iterative loops. So this is where we're creating our quality score. So we have some print statements. We're setting the research variable to get the output from research results, initializing the quality score to 0, and then we're doing some checks with the word count and if there's any terms like data, study, research, statistics, percent, which will increase the quality score accordingly. Then we have some print statements and it'll return the new state with changes in the key of quality score and step count. We also have an improved research node. So for our prompt, so this improved research node improves research quality through iteration, depending on that quality score. So we have a print statement, and then we have our prompt, improve and expand this research about our query. We give in our output from our research node, and then our current quality score. Provide, and it says provide additional details, including specific data, statistics, recent studies and research findings, concrete examples, and expert opinions or industry trends. So with our prompt, we'll invoke our LLM, give our original research node output, and then our improved content. So that's we're throwing in our response that we got from this specific node. If there's any errors, then it'll throw it our way, and it'll return the new dictionary with improved keys on research results, iteration count, and step count. And then if it should continue improving. So this is another function that decides whether to continue improving or proceed. So it'll get our quality score, our number of iterations, but we can only have a max iterations of 2. So if it tries to go for a third one, it'll just get sent straight to the analysis node. So if the quality score is less than 2 and the iteration is less than the max iteration of 2, it'll give us a print statement and it'll say continue improving and it'll return the string improve. Else, if it's over the max, if the max iteration has been reached, then it'll proceed to analysis and return the string proceed. We add on another function called create iterative workflow, and this creates the workflow with quality-based iteration. So we create the graph or the application using our research state. We add our nodes. So this time we add our research, analysis, summary, but now we add our quality check, so our quality score and our improved research. And then we create our connections. So research should go to quality check, and then we have our conditional edge. So we start off with our source node. So it's the quality check node. And then this is what decides what path to take. So it's the should continue improving function. And depending if we get the improved string back or the proceed string back, it'll send it to different nodes. This one right here, it connects improved research to quality check. So loop back to quality check after improvement. So it'll test over that output again. And then once everything has gone through those iterations and everything is good, it should be sent to the analysis, and then analysis will get sent to summary, and summary is the last step, so it's connected to end. We set our entry point, and then we compile it and return the app. Now let's go ahead and test it out. So we print out some statements, we create the app, and then we create our initial state with our query quantum computing applications. We invoke our LLM, and then we have some print statements. Let's go ahead and test it out, see what we get. So our research node is conducting the research. And then it gives us some extra information like the word count, if had any references to data, it gives us our quality score, the decision it made, and then it continues on with the process to analysis and then summary. And then it gives us our workflow results. So it took a total of 4 steps, 0 iterations, and we had a final quality score of 3 out of 3. So that's the first time it ran. Gives us our research length, so the characters in the output, and then our summary. Any questions? All right. Now we're going to build a LangChain agent. So let me paste this real quick. So this is, again, using the deprecated way of creating an agent. So notice how over here we're creating all our tools. So our research tool, analyze tool, summarize tool, fact check tool. And then after we create those functions, then we actually set the tools up within this list. But that's not going to work. So let's go ahead and convert this to the new way of doing things. So with prompting, always give as much context as you can so that AI knows uh, more about what's going on and so that it can help better. It's kind of like uh, explaining something to your assistant. If they don't get the full context, it's going to be difficult for them to complete the task. So I just give my prompt, and then usually I'll say like my file, and then give the code. So notice the difference uh, from what we had before. For example, the research tool. Here we have a function named research tool, but now we just actually use this I forgot what this called, flag or decorator on top of it to specify that it is a tool. So we copy this and then let's just change it. Another thing is that since the new way of doing it won't require this specifying those functions as tool anymore. You just add it on top. So we have our research tool. It'll research any topic to gather information. It'll print out a statement, and then it has a prompt: research and provide key information about the specific topic. So the query. And within your tools, always include a doc string for sure, because that gets converted to the description of that tool. So that way the agent can look at it and see what best it can use to utilize in getting the output that you want. Here we do have a list that collects all the tools so that the agent can just quickly go through it. And then we also have let's go through the other tools real quick. We have our analyze tools, summarize tool, and then fact check tools to verify the accuracy. So now we're going to create the agent. We're going to have to update the agent to the new version as well. So I'll say, can you modify this code as well to use the new version? And we gotta wait for this to finish up. If you copy it too fast, it's only gonna get a portion of it. Go ahead and add this, or let's see if this would work. Let's see. I think we're gonna get some it's still going to run, but it'll say that this is deprecated. But let's try it out. Notice that it's not highlighted green or yellow, and it's just plain white. So it says that it's being utilized, but it's deprecated. Let's see what the other one. And for this crossed out one, I don't know what it means, but the thing about LangChain is it usually does give you information of what's happening. So let's see, the function create React agent is deprecated. So it's been moved to LangChain.agents. All right, so yeah, we already have it. It says create agent.
Yeah, you got to get rid of the underscore react. That's what I had to do
Mhm.
to get rid of the deprecation warnings.
Uh,
And then you have to go in the code and actually change all the instances of create underscore react underscore agent to
okay.
create agent instead. I had to do some changes.
All right. I'll show you guys a way to do that too quickly. So if you do Command F and then I think it's this. All right, let's actually put in the term first. I think this one do. Let's try this. Or no, actually you gotta press this drop down button right here, and then it'll look for everything that says create React agent, and then you just change it to it was you said it was create agent, right, Nick?
Yep.
All right. So this fast way to do that, and then you just do replace all.
And I think I had to make some changes beyond that as well, but that was hold on, let me pull up mine. It was create agent tools, create agent. Yeah, so it create underscore agent only needs to take in two arguments, is what I came up with. It needs the first argument is the LLM and the second argument is the tools. I did not give it a state modifier.
Okay.
LLM tools. I don't know. I maybe run it and see what happens, but
Yeah, yeah, let's see what happens, and then depending on the output, let's change it up. Uh, all right. So first, let's go over the create research agent. So we have our doc string, then print statements, then we pass in our tools. We probably don't even need this pass in this whole thing. Probably just pass in tools, or it could probably find the tools from this scope right here. But let's just leave it. So we set the variable agent to actually be created, like with the LLM and the tools, and then we just return it. And then we have a function that says run the agent. So agent will equal that function above, and then we have our results. So it'll invoke the agent and then give the message from our user and the query. So we get the final message, we get the content from that response and return it. And then, all right, now we're going to add a test function. We're probably going to have to change that too. So for that, the prompt I will be using is I also have to change my test function. I will give you my full file as context and give you the test function as well. So whenever you do something like this, make sure that your file doesn't have any security uh, or privacy issues that can be stored in the model just to be extra safe. I usually just throw in different variables if there's any PII. But after I throw in that prompt, I'll say file and then test function. And then I'll copy my whole file. And then my test function. What is it? Yes. So they're saying it wants us to use create rack agent. So I'll specify that it is deprecated. Any questions so far? I know this is a longer lesson, but we're almost done soon. This is the last step. All right. Isn't that what we just had? Yeah. All right, let's test the agent real quick. See what we get back. Kind of important. All right, we're just gonna have to get rid of that agent executor. The agent got
Yeah, it doesn't like the state modifier, that third argument you passed in.
create agent.
Right.
Oh, yeah, yeah, okay.
Yeah, that third one. I had to get rid of that too.
Okay.
Put a closing
Oh, yeah,
parentheses in it
yeah.
and get rid of that comma, I think, and you'll be good. Or at least that step will be fixed. I had to
Mhm.
do a couple things.
Sweet. All right, so for our query, research the benefits of renewable energy. The agent is researching it. And then it determines that the summarize tool should be used. For the next query, fact check, using the fact checking, researching, summarizing. So it works. All right. Now for part 7, we're just comparing the different approaches between LangGraph and agent. So we're importing time. We're creating both systems, testing the query, and then we test LangGraph and timing it, and then testing the agent with the time as well. And then we have some print statements to compare. Now let's run all the tests. We're not going to do the test recommendations. Let's verify that everything works. All right, is there any questions? We're at the end of the lesson, so or end of the lab. Is everything kind of making sense? Yeah, with this, it's easier to understand it with a more hands-on approach compared to just reading everything and because it is very complex and there's a lot of different components that connect to one another and loops, and so you'll get a better understanding as you uh work through it. But also there's like the past weeks, the topics on the past weeks kind of make more sense now too as we're going through LangChain, and are things kind of clicking with like memory and and CI/CD. Sweet, sweet.
I don't know, Eric, if you wanted to maybe riff a little bit on three-tier memory in this file, like how specifically session, long-term, and vector might be, utilized within the lab that we just did.
Mm.
You don't need to if you don't want to.
It's kind of more difficult on just the singular lab, but for a vector database, you could kind of think about it through RAG. So whenever you updated, created those documents, then it had uh, you embedded them and chunked them up. So that would count as a uh, yeah, that is a vector database. In this lab, the state counts more as the long-term memory. Short-term memory would be, I guess, what's happening within each node or function. The, uh, does that kind of clarify it at all? I know that was a more simple uh, or shorter way of explaining it, but did you need me to elaborate more?
No, it was interesting you said state is serving as the long term, when that seems like it's state per session, right? Because does that persist between sessions, the state file?
So yeah, so the state file is kind of so the state file is utilized throughout the whole application, but depending on when it runs through the node, it will update the specific values for the keys. So it will, yeah, that's how I'm thinking of it. It just gets continuously updated, but like within uh, that node, it will, or within that node or function, it only really remembers what is happening within there unless you repass in that state again. I mean, it's not the best example, but that's the closest I could I could kind of compare the different tiers of memory into LangChain in this lab.
I dig it, man. Thank you.
Mhm. All right, so all tests completed. We already looked at a bunch of the other tests, but besides the comparison, so let's look at that. So building linear workflow. So these are just the print statements. So we have our LangGraph approach. It gives us the time. And then for our agent approach, it gives us 1.72 seconds. But wait, there's an error that got outputted as well. And yeah, we can do some digging into that, but that might take a bit. As long as you get the different comparison and the uh the overarching scheme, you're good to go. So yeah, are there any questions before you guys start the challenge? All right, let me end the recording.